Welcome back to the Deep Dive. Today we are taking on something that, well, sits right at the very foundation of modern science.
It really does.
When you think about physics, you think about Einstein, you think about special relativity.
And that core idea that the speed of light, c a dollar, is the ultimate constant.
Right. The same for everyone, no matter how they're moving. It's settled science, isn't it?
That's certainly the textbook definition. But the deep sources you've given us, they tell a pretty dramatic story of a model that just rejects that specific premise.
It claims that CI dollars is constant, okay, but only within one unique reference frame.
A kind of absolute medium they call the electromagnetic field space.
And here's the hook that, for me, just grabbed my attention immediately. This wasn't some, dry academic debate.
Not at all.
You essentially put a jury of top generative AIs, we're talking Gemini, ChatGPT, Claude, Grok. You put them in the judge's seat.
Right. They had to review the evidence, analyze the math, and then cast their votes in what one of the sources pretty amusingly calls court politics.
The whole mission was to analyze this argument, which says that special relativity, while mathematically beautiful, it has a fundamental structural omission.
It prioritizes its own internal consistency over, well, what they call verifiable physical reality.
And the really shocking outcome of that AI vote, we'll get to the full results, but the majority sided against Einstein's foundational definition.
Which is why we're here. Our goal today is to really understand why.
So let's clearly lay out the three positions the AIs had to pick from.
Okay, we can think of them as three factions in this theoretical court. First up, position A, the textbook view.
The Einstein faction.
Exactly. This says light speed cellar is a constant in any arbitrary inertial frame. The big strength here is internal consistency. The math just works perfectly for any observer.
Okay, then there's position B, the physical realism model. The sources sometimes call it the Cyanide Chat faction.
And they argue that Sellers is constant only in one place. That absolute unique reference frame, the electromagnetic field space.
So their priority is aligning the theory with, external measurable reality.
And then finally, position C, the reserved position.
The neutral party.
Basically. This faction says, look, the critique from B is profound, especially on physical observation. But they remain neutral, saying they need much more large-scale empirical data or a fully unified mathematical model before they sign off.
The AIs had to choose, and their choice forces us to look again at what we thought we knew. So let's unpack the core conflict here, starting with that classic thought experiment.
The light clock.
The light clock inside a moving train.
It's the perfect place to start. It really highlights the fundamental definitional difference between A and B. So we've got a light pulse. It's moving vertically between the floor and ceiling of a train that's moving very, very fast.
And from the perspective of the observer inside the train, what the sources call the design plan space, the light is shot straight up, hits the ceiling, comes back down.
Right. If the ceiling is 10 units away, the path is 10 units long, and it takes 10 seconds.
Which makes total sense if you prioritize the observer's immediate relative frame.
It does make sense, but position B argues this relies on a Galilean transformational intuition. It's just disguised in the math of relativity. The problem comes up when you acknowledge the actual physical stage.
The train is moving through this absolute electromagnetic field space, what they call layer B.
And if that train is moving sideways, let's say at 10% the speed of light, 0 on CHEO, the ceiling is no longer just a static target. It's a target that's constantly moving forward through the field.
Oh.
Precisely. If light really has to move at $10 relative to that absolute field, and the ceiling is moving, you can't aim it vertically. It would miss.
And this is the heart of position B, right? The principle of deviation shooting.
Deviation shooting. I love that term.
It's like a hunter aiming not where the duck is, but where the duck is going to be.
That's the perfect analogy. To intercept that moving ceiling, the light pulse has to be aimed slightly obliquely forward in the direction of the train's motion.
So if the height is 10, and it takes 10 seconds, and the train moves 1 unit in that time, the light has to aim for the future coordinate. $10, Z $10.
Exactly.
But wait, if the light travels obliquely, that means the path length itself changes.
It absolutely does. Instead of that simple vertical path of 10 units from position A, the real physical path the light takes in the EM field is longer.
It's the hypotenuse of a right triangle.
It is. It's about scorn 102 plus 12, which is roughly $10.05 units.
And that tiny difference, $10.55 versus $10, that's the whole war. The length is different, but the speed cedar is constant relative to the field.
The time taken is $10.05 Sanders, and this is where the critique gets really serious. Position B is arguing that position A, Einstein's view, is essentially using a relative coordinate system that just sort of mathematically absorbs this extra distance, that 0.55 units, and the deviation shooting itself.
So it makes the path appear to be vertical and short to the person inside the train.
So Einstein didn't get the math wrong. He just chose a coordinate system that already compressed or, ignored the physical reality of how the light pulse was moving through the medium.
That's the core of it. And what makes this so compelling is that this isn't some brand new idea. The sources connect deviation shooting directly to Bradley's aberration of light.
From 1728.
Wow. The famous astronomical observation where you have to tilt a telescope slightly to catch starlight because our planet is moving.
Exactly. Bradley proved that if your instrument is moving, you have to account for that movement relative to the space where the light is propagating. Position B uses this as proof of external consistency.
So you have to account for the train's movement relative to the absolute EM field.
And that shifts the whole philosophical ground. It means the light clock experiment isn't just about relative observation.
It's about defining the nature of the stage itself. And if we acknowledge that stage, layer B, then Einstein's picture, layer A, is fundamentally missing a dimension of physical travel.
That's the perfect transition, because this critique forces the supporters of Faction B and the AIs to set up a new hierarchical model of reality. If the light clock is flawed, how do you fix space and time?
This is where we get the three distinct layers of space, which Gemini noted connects physics to some really deep structural analysis. What are these three nested dolls?
We start with the deepest layer, the core reality, layer B, the electromagnetic field space.
The absolute reference system.
Yes. It's the only place where the physical action, the propagation of light, the movement of the train truly happens. It is the objective field.
Okay, so that's the territory itself. What's layer A?
Layer A is the design space. It's the mathematical abstraction. This is the world of special relativity. The math is simplified and beautiful because it defines space in a way that just prioritizes the relative observer.
And like we said, it achieves that simplicity by mathematically compressing or omitting the need for that absolute field.
It's the map, not the territory.
So layer A is the highly functional blueprint we use for things like GPS, but it leaves out the messy, complex reality of the physics happening in layer B.
Precisely. And then there's the third layer, which is crucial for the critique. Layer C, the perception or camera eye space. This is what you, the observer, actually see and record.
And layer C is where this concept of temporal thickness becomes so important.
It is. Time isn't instantaneous in observation. Because light takes a finite amount of time to travel, the image your camera eye receives isn't a single unified snapshot of a moment in layer B.
It's a composite image.
Assembled from signals that departed from different places at different times in the past. It has, well, thickness.
That makes perfect sense. I mean, if I look at a galaxy, I'm seeing it as it was millions of years ago. But the sources are saying we have to apply that same rigor to everyday local observations.
Absolutely. And the visualization here is the nested light cones. Your current moment, is an intersection of multiple past light cones. Light from something close by just left a moment ago. Light from a distant part of the same thing left a long time ago.
And all these past shells of light reach your eye at the same time, forming this complex, nested structure of perception.
To make that really tangible for the listener, the sources gave this fantastic coordinate breakdown, the $60 times 60 times $60 train example.
Right. Let's use that to really drive home this time delay.
So it's a relatively short train, moving at 1cc10. We have two static cameras, both 100 units away, watching the train as it passes the t-dollar point in the real layer B space.
Okay, so camera A is positioned directly sideways, perpendicular to the train's motion. We're getting a side view.
For camera A, the light from the front, the center, and the back of the train, all events that happened at the exact same physical moment, $2 in the field, arrives at the camera almost simultaneously.
The light paths are barely different, maybe 100 seconds to 100.02 seconds. The image is clean.
But camera B is viewing the train head-on, along the axis of its motion. Here, the directional delay is massive. If the train has a length of, say, 4 units, the light from the back end has to travel 102 units to reach camera B.
And the light from the front end only has to travel 98 units.
That's a 4-unit difference in distance?
Which, since light speed is finite, translates to a 4-second difference in reception time.
4 seconds. For a short train moving at a relatively slow speed, I mean, think about that. The camera receives the signal from the front of the train 4 seconds before it gets the signal from the back. Even though both points existed at the very same physical instant, $2.
So the image camera B records is completely warped, smeared. It's not a photo of single moment, it's a time-delayed sequence.
It's a perfect illustration of temporal thickness. The sources compare it to Dürer's perspective grid. The image you see in layer C is a perspective projection full of distortion and delay. It's not a true snapshot.
An orthographic projection.
Right, so to recover the true world line, to understand what really happened in layer B, you have to do a complex reverse calculation accounting for all that direction-dependent time delay.
And if you don't do that, you fall for what the sources call the idealistic inversion.
Which is the philosophical mistake of thinking your perceived reality, layer C, is the same as the underlying absolute physical reality, layer B.
And this is exactly why the AIs were called in, to judge which theoretical structure avoids that fatal inversion.
All right, let's get to the verdict. The AI judges, Gemini, ChatGPT, Claude, Grok, Perplexity, Fellow, DeepSeek, they had all this evidence, the flaws in the light clock, the proof of temporal thickness. What did they decide?
The outcome was a pretty strong mandate for the challenger. A significant majority of the AIs, Gemini, ChatGPT, Claude, and Grok, they explicitly sided with position B.
They supported the concept of the absolute electromagnetic field space.
That's truly remarkable. It suggests the structural critique, the three layers in deviation shooting. It provided a more compelling argument for physical reality than the mathematical elegance of SR.
And the majority AIs, they really converged on 3 key points.
Okay, what were they?
First, physical realism. They agreed that B just does a better job of describing the mechanical, physical process of light propagating through a medium, the EM field, and it directly reconciles the theory with historic observations like Bradley's aberration.
It restores the realism of physical existence.
It addresses the how of light travel, not just the what.
Okay, and the second point?
Logical integrity. The AIs recognized that position A's defense of that vertical light path, it requires a coordinate transformation that kind of hides a physical contradiction.
Whereas position B, with its demand for deviation shooting,
rigorously enforces the no velocity addition to light rule in the absolute frame. It's a more honest accounting of the physical path length.
So the AI saw A as a kind of mathematical shortcut that bypassed the messy physics. What about the third point, the structural one?
That's the most philosophical one, structural integrity. The AIs loved the B model for its clean separation of the 3 layers, the field reality, the mathematical abstraction, and observation.
E, A, and C.
And they concluded that only by keeping that separation can you avoid the idealistic inversion, where we mistakenly believe our time-delayed relative perception is the same as the absolute physical field.
So it sounds like the AIs judged SR not as bad math, but as structurally incomplete physics. They were asking, why define space only by the observer if the physical process itself requires a fixed medium?
That's precisely the nuance they hit. But we have to talk about the 2 dissenters, Perplexity and PhiloDeepSeek. They chose the neutral position C.
And they didn't disagree with the physics of B, did they?
No, not at all. Their rationale was deeply pragmatic. They valued B's insights, deviation shooting, temporal thickness, but they pointed out that special relativity, position A, is the established working model.
It's integrated into everything from GPS correction to cosmology.
They were essentially saying this critique is brilliant, but before we abandon the global architecture that's currently working, we need more than a thought experiment.
They need large-scale empirical tests, like measuring light speed near objects moving at near Usemaldo velocities.
And they need a fully comprehensive mathematical integration model that can seamlessly bridge A, B, and C.
So they respected the logic, but demanded a complete testable replacement system before switching sides. It's a kind of cautious scientific conservatism.
A very fair position. But the majority verdict stands. The AIs assessed that Einstein's theory, by focusing so much on internal coherence, it omitted the necessary definition of the spatial environment. And they endorsed B as the logical path to restore that realism of physical existence.
So what does this all mean for you, the listener? This deep dive is about more than just a battle over relativity. It really demonstrates that even the most established scientific principles are vulnerable to structural critique.
If they omit defining the fundamental reference frame, the very stage where reality plays out.
And whether you're defining a physics problem, a data model, or even a philosophical argument, the sources are showing us this critical need to distinguish between your simplified design space, layer A,
The actual physical environment, layer B.
and your delayed subjective perception, layer C.
And if you confuse C or A with B, you've committed that idealistic inversion.
It challenges us to never mistake the elegance of the map for the complexity of the territory. And it reminds us that our perception is always temporally thick. It's never instantaneous.
And that reflection on temporal thickness, it leads us right to the final provocative thought that was suggested by the researchers behind position B.
Yeah.
They hint repeatedly that the logical next step is to describe this multi-layered, time-delayed reality using complex space.
Complex space. So using both real and imaginary numbers. How does that help restore the thickness of reality?
Well, the complex component, the imaginary axis, it provides the mathematical tool to express this temporal thickness. Remember how we said layer A, special relativity, essentially compressed the full physical information of layer B into a simplified projection?
Right.
The goal is to use that imaginary axis to mathematically uncompress that spatial definition, restoring the information about time, depth, and delay that was previously, dried out or ignored in the standard models.
So it's about creating a richer, more honest mathematical definition of the physical stage itself.